Hey everyone. This will be hopefully a really short correction to my part two, reverse engineering of a Windows snipping tool. Um, so what I was doing, I was making a binary patch and mostly reverse engineering for like 2+ hours of Windows snipping tool. And what I was trying to do, well, in this part, I was trying to remove this bottom snipping tool is moving message. And I made a couple assumptions on the way there that I didn't notice right away. So let me show you what happened. First of all, if you start the snipping tool with my fix, as you can see, the bottom banner is gone and it seems to be working just fine. Well, sometime in the past, I recorded a video where I explained what Windows error reporting is. And I have a tool which is called WERSetup. It's kind of like a Windows error reporting setup. And what it does, it sets up Windows error reporting for user mode programs. So if any of them crashes, it will place a crash dump into this folder. So if we quickly open it up, it's in C crash dump. So originally it should be empty. And the reason I'm using this, WERSetup tool or Windows error reporting is that when something crashes on the system, the operating system, Windows in this case, will create a crash dump in this folder. I usually use it for my development testing and in this case for reverse engineering. So after I recorded part two, I started noticing that when I run my snipping tool, the patched one, it would create a crash dump, which means that the snipping tool was crashing. Let me try to replicate it. So I will probably have to do it more than once. So I don't know what exactly it depends on, but you see, like sometimes the snipping tool doesn't start, and over here you create a crash dump. Now, as you can see, there's no rhyme or reason. Right now it's the 7th copy, but it can be, 10th, 11th, but so forth. So that obviously raised some alarms in my case because the original snipping tool, if you start running it, it would not be crashing. So something in my modification in the second part was causing this. So, and that's why I decided to record this video to kind of show how you can diagnose crash dumps and how you can actually correct your error, and I can kind of show what I have done wrong. Okay, well, first thing first, we need to open the crash dump that was conveniently created here. And by the way, this is the power of the Windows error reporting, so make sure you set this up. It is very helpful. In this case, because I have Windows debugger, WinDbg installed, it kind of like sets itself as a handler of the crash dumps. So let's double click to open it in WinDbg. And over here, you can see right off the bat that we're getting fast fail guard IQUAL check. Now, if you search by this error, you will realize that this is a fault in Windows Control Flow Guard. Now, this tutorial is not about Control Flow Guard. I kind of like ran into it quickly with debugger. But basically, if you want to read, I'll post a link in the description. It's a security feature in Windows that you can enable actually for your software, and evidently Snipping Tool has it enabled. And what it does, it basically makes sure that no exploit inside the function, inside the module, inside the process can call certain functions that were not allowed by Control Flow Guard. So in this case, it really made no sense. And by the way, this exception would be raised if the Control Flow Guard check was not valid. And it would not be valid if Control Flow Guard's bitmap, it's kind of like a small area of memory that is dedicated to each API that is allowed to run in the process. If that bitmap was somehow overwritten or somehow messed up. Now, obviously, because I was applying a patch, my patch was number one culprit in this case? Well, let's try to get a little bit more information. If we click here at bang analyze -v, we can see that, let's see, well, it's telling us that the offending function is this C toolbar clear background button procedure, which, as you can imagine, we did not touch. But evidently it had, control flow guards set up. And if we look at the call stack of the thread that crashed, yeah, it was trying to do some cleanup, Windows procedure, just like nothing. It's just like nothing that really tells me, why this thing failed. And it kind of failed later down in our do layout. The interesting thing is that it did not fail on the first try. It failed on one of the repeating tries. So what this tells me is that there is definitely some memory corruption that happened, and my first step was to remove my patch. So first of all, let's remove the crash dump, and I will keep this window open so that we can kind of see if there is any new crash. And the first thing first, we need to remove the patch. If you remember, in our cheat sheet here, if I scroll all the way down, this is a notepad where we were writing all of our steps. What we did, we replaced original functions, which were these, with our modification here, and this is the machine code with what we replaced it with. So what we need is undo or replace this with this. In other words, just bring it back how it used to be. So let me do this real quick, and let me put this down here so I could see it. So first I need to find that location. And as you can see, it's right here. So I need to replace this with this. And let me do it real quick. So it's 89, 45, C7, 85, C0, 0F, 88, 75, 02, 0000, and save. So this should technically undo our patch, and instead of using idle, let's just run it. And as you can see, the bottom part is back. And just to confirm that I'm not getting these crashes in the original or clean, in double quotes, snipping tool, let's just run it many times. And as you can see, I have a lot of them open, and I don't see my crash. So this tells me that something inside of my patch is the problem. Well, let's review what we've done here. So again, if I bring up my notepad, so as you can see, now this is the patch that was done. I kind of created a pseudo C version of that. So I looked inside of this calculate screen sketch banner height function, and at first I wanted to completely remove it. And then I said, yeah, it seems like it does something. It does some verifications. It does some displaying, showing of some controls. So it might be necessary. So what I decided to do, I decided to keep it, and instead just to override its return value with 0, assuming that it would always return success, and kind of like set the height that the function was calculating, kind of like I was supposing it was the main job to calculate the height, and I would override it with 0. And the height, again, if you remember, was this thing, right? So I go back to pencil. The height was the height of kind of like this part, right, of the banner that we were trying to remove. And that seemed to be, kind of like a good solution, and it was working. So let's go back to our IDA and to our disassembly of this function in the actual binary and see what could be the problem there. Now for that, I will bring it up in my disassembler. and kind of like do everything that I've done in part 2, so I'm not going to go over this, so I need symbols. And at this point I kind of started from scratch, so all my breakpoints are erased. So, but it's really easy to recreate since we have nodes. At first I will put a breakpoint on WinMain, and I will start the snipping tool. I'll let IDA initialize. At this point I need to load symbols on the right pane here for the snipping tool itself. The reason I can do this is because it's a Microsoft binary, so they have them on a public symbol server. If I double click and locate the function that I was actually patching, I click Control F, Control V, and this first one is the function. So let's double check. Yep, so as you can see, this is the function that we were removing. So let's put a breakpoint here and run. So the breakpoint hit. At this point, let me remove it from here and step out. And this is the location. Let me just put a breakpoint here where we were actually patching. If you remember, now this part here that says old, like when we were putting EAX result of the function into this location on the stack and then we were checking the result, it's this part over here. But notice what is happening here. Now if I step a little bit further, do you see that the return address is actually not 0? And if you remember what we were doing here, we assumed that the return address is the H result. And I kind of said like, hey, this function would always return 0, but let's just, for the heck of it, let's just override it with 0. So what we did over here is that we artificially set this result as always success. Well, in this case, the function actually failed. And obviously, we're not the authors of this code, and it could have been doing something here in the else statement, right? When the function actually fails, that we were kind of skipping. And this failure that we over here assume to be success is what was causing corruption of the bitmap for the control flow guard. Now, just to kind of see what the heck this thing is, we can copy the value, open WinID search, go to Tools, Error Code Search, and paste it in here. Let me remove all the zeros, and let's see. Yeah, so for some reason, you see it's giving us invalid window handle, and that's the return from this function. So my guess is that maybe at some point the window is not created yet or something is not ready, and when we receive this error, let's keep stepping, you see the function immediately quits. So in other words, we're not doing any of this stuff that we're doing here. And the problem is that, well, with our patch, that we pretty much said, oh, no problem, like this line doesn't exist, just keep going here, is that all of this stuff was not supposed to be happening. In other words, we kind of like removed this stuff, you know, and we put like, okay, this else doesn't exist, just do the work, right? But this is not the correct way to do it, and this is what created this bug, which was kind of like interesting, because again, the snipping tools seem to have been working. It would just like crash randomly, but this is kind of like really bad and nasty bug, which I was able to catch in this case by using my crash dump folder and my Windows error reporting setup. So just kind of like a good example for you how you can benefit from it. Now, important part for me was that I was able to catch it quick enough, and I knew that something inside my patch here was the culprit. Okay, well, having said that, we still need to patch our function. So the difference that we need to do is that we need to remove this and actually remove this, right? So result we cannot override it. We actually need to check the result, and if the function fails, we need to gracefully fail and do whatever the author assumed to do. But our patch is actually to do this, right? So because we want to eliminate the height of the window. So let's see, how can we do this? Well, first thing first, we need to see our machine code instructions to see what we have to work with. And the reason I kind of, prefer to look at machine code instructions is to be able to tell how much space do I have for the patch. The problem is, I alluded to it twice already, but let me repeat it again. You cannot just shrink. Let's say if you wanted to remove these 3 bytes, you cannot just like take this one and put over here. You cannot just shrink something, and on the same token, you cannot expand it. The reason being is that all of the offsets inside the assembly language, they will be all broken. So if you expand it, it will definitely crash the process, and you will destroy the PE executable. So the only way you can do is you can use the space that is available for you. In this case, though, again, if you look at our sudo C, we have to keep pretty much everything, right? We have to set our result and we have to check for it. What we have to do is to actually add something to it, and that creates a little bit of a problem. Now, these 2 commands is something that we are intending to keep. The same way as with this one, because that's what's setting our hResult. Again, hResult is a local variable, and this machine instructions, this move, is the one that is setting it. Well, the question is, how do we reset this thing to 0? And for this case, we have to kind of like look at what is happening here, and IDA in this case is very helpful. Now, if you click on this var_hc, it's kind of like IDA's way of pointing to a location on the stack where it's keeping the height. In other words, where our out height is located, kind of the address of it. Now, if you look at it, originally it passes its address in R8, which, again, if you remember our calling convention, R8 is the 3rd parameter for the function, and the function in question is this one, right? Call screen sketch bar height blah blah blah, and it's passing it as this pointer here. And the reason it's the 3rd parameter is because the 1st parameter is hidden, and it's this for the class. So the question is, how do we set this thing to 0? And the answer is actually staring right in our face. If you look right above it on this line, this move is also writing into the same location, except that it's writing an EBX. If you remember, when we were actually looking at our patch, let me scroll all the way down, the patch actually consisted of writing EBX into 2 locations. And if you remember, even before that, if I click on EBX and start scrolling up and see all the location where it's set, now over here it's being used, and if I keep scrolling, right at the top of the function over here, you can see that EBX is actually set to 0, right? When you XOR something with itself, it sets it to 0. So what this means is, if we scroll all the way to our function of interest, this line over here, this move, is actually sets our variable to 0 before this line, the load effective address, sets the address of this variable. Sorry, I need to remember not to double click. Before this line actually provides the address of our variable into the function, and the function itself sets this variable to the height. Well, what do you think would be the correct way to change it? Well, we basically need to reset this to give this function some bogus address, because originally it's already set to 0. We don't need to set it to anything else, but we need to provide an input parameter, a pointer to this function. So the easiest thing to do, in my view, is to give it some bogus address. It will write it somewhere, but we don't really care. Now, which address do we give her? I mean, her or him, the function. And the thing, if you look down over here, this is where it sets the result, or h result, that we receive from the function into our local variable hres. So if we replace this thing with the address of this variable, the function will write into this location, return, and then this instruction, this move instruction, will write the result into it, effectively overriding whatever the function calculated for us. But the value of the height will remain 0. So I think this is much better patch than what we had before, and the only thing we need to do is to implement it. So before we do this, we need to see what is the address of this offset here. Again, unfortunately, IDA is not very helpful, but we can use these 3 machine code instructions. If I copy them and go to online disassembly, you actually see what the instruction is without all the IDA additions. Okay, so what we have here, and let me put here bad patch, right, so I don't do it again, and let me write a better patch. Okay, so this, just create a line here, kind of like part 2. So this line basically gives us the offset where there is h result is written to, and we can just set it as offset where h result is written to. All these nodes, guys, seem to be kind of ridiculous once you're doing and working, but you will definitely appreciate these later on, like I did, because I saved this notepad. I was able to actually retrace my work. Okay, so what we need to do is replace this line. Let me see, what will it be? Again, using disassembler. Okay, so replace this with, okay, we don't know what the machine code is, but instead of offset 35, we need offset 39, right? So we need to replace this with this. And again, I kind of explained it, but let me kind of go over it again. So in other words, over here, we provided the address not of the height, but of this variable, okay? And so let me get the machine code for these instructions. And I can put it here, x64. And these are the machine code instructions. So let me do here. So if you see, we're literally replacing the offset, and it's very simple. You just replace CB with C7. That's the only thing we need to do. Now, because this instruction is very, I would say, is used in many places, let me get a few bytes that follow it. So, for instance, V3. I usually try to make sure that, you know, this combo is not like something that repeats in many places, because compilers just love to put repeating code, you know, code patterns. So, okay, well, this seems to be it. Just to be sure, let me copy a little bit more, a few instructions there in case it is found. So that's CF, and let me do this one just in case. And again, just to put a little bit more entropy into it. Okay, so at this point, Just need to replace this byte with this byte, and we'll use this whole shebang to locate it in the binary. So at this point, let me close it. And I don't need IDA. Let me minimize all the stuff. So here's our executable. Let's open it in hex editor. And we go search, find. Let's specify this whole sequence. Okay, found. And let's make sure it... Ooh. Okay. And this is the situation that is not good, because what happened is that we found two locations where our stuff was found. Okay guys, sorry, need to open it again in IDA. Should have not closed it, but it's pretty easy to locate it. This is usually a downside of this kind of binary patching, because you have to have a very good entropy on the bytes, because otherwise, yeah, they'll be reused and you'll be out of luck. Well, at this point, because we don't know which part is which, so we have to give it a little bit more entropy with the few other instructions. Okay, so we're pretty much quickly loading symbols, and go here, look up our function name, the culprit that's setting up the height, and Control F, Control V, that's the first one, and set a breakpoint, run till we hit it. In this case, let's remove the breakpoint, step out, and this is our function. I'll put a breakpoint just in case. And in this case, we need to see opcodes. Okay, so let me see, what did I get here? So I got 4C, so I got this line, that line. Okay, and let me add this line. To the mix. So let me stop it, but I will not be closing IDA in this case. Okay, so let me try to search by this longer sequence. So again, we're opening it in hex editor. Search, find, hex values. Okay, so let's try again. Okay, and now we didn't find it. Okay, well, should have done it from the get-go. Again, guys, this is a good example to use something with more instructions, not just something short as this one. And what we need to do, we need to replace CB with C7. So let me just drag it over here. And, okay, this CB becomes C7, right? And then 8B55, yep. Okay, this patch is really simple, just one byte. And before we go into testing it, my preferred way would be to actually use disassembler to kind of like look what was happening. Now, I didn't save it in IDA because for some reason IDA remembers the old layout of the binary, and it won't show correct disassembly, so I have to go over it again. If somebody knows how to do this while you have previously saved work in IDA, how to make it redo the disassembly, I would appreciate it if you can tell me in the comments. Now, for now, I'm just doing what I've done before. You probably saw it 50 times. So breakpoint on WinMain, then I'm loading symbols for the snipping tool. Double click, and I should probably memorize the name of this function by now. And so I copy it, Control F, Control V, first one. Have to click here and set breakpoint, run. Okay, hit the breakpoint. Delete breakpoint, step out. This is a function. Let me set breakpoint just in case. And let's see, what did we accomplish? So, if you remember, this 8C, well, this offset here, which is not 8C, this is the location of the height. Like you see, like over here, the function is reading from it to do some other conversion here. And over here on this load effective address, that's when originally we had the address of 8C. Well, right now, we gave it a different address. We give it the address of this H result, which will be later overwritten. So it's kind of like basically our way of saying return something and then we'll discard it. So at this point, as you can see, the function returned an error. And when we step through, the function exits. So if we run again, at this point, it returns success. So we should keep going. And if you remember, where's our 8C? Now on this line, it should read the height of the banner. So over here, and as you can see, ECX is 0. So this is technically what we should have done in the beginning. And now if I disable this breakpoint and let it run, as you can see, we just removed the bottom part of the snipping tool. Kind of what we were supposed to do in the beginning. And this second edition kind of shows you, first of all, what kind of errors you can make during reverse engineering and how you can correct them. Now, this is very important to run the Windows error reporting setup on the operating system so you can catch these things. Now, before we actually finish this, let me save it and close IDA. We need to test to make sure that our current patch is actually working. Well, first of all, if you start the snipping tool and make a snip and start another snipping tool, make another snip. So as you can see, you can run multiple snipping tools and you can make snips. So this part is definitely working. Okay, so let's need to save. And one last thing, let me try to run like a whole bunch of these and make sure it doesn't crash. Now, I'm not saying it won't crash, because again, everything is possible. It's reverse engineering, and you're kind of like, trying to modify an already compiled program. But it is a good way to see, with the use of my WERSetup and Windows error reporting tool on a system-wide level, to make sure that nothing is crashing when we run this, run our modification. Okay, well, let's see. It seems like we started enough snipping tools to tell us that it is not crashing. Okay, guys, at this point, I will conclude my correction to my part 2 of this very long reverse engineering part. And in part 3, we will continue with reverse engineering and modification of the Windows snipping tool. So see you there.